Welcome to Veteach. Today's class we will continue the discussion about architectural components. The other one, deployment. So what do we have in a deployment? A deployment is represented by a node, a physical existing node, geographically at different locations. So how do we represent them? So a node is a physical element. A node is a physical element that exists at runtime and represents a computational resource. So what do you mean by computational resource? It means that it has the capability of both a memory, its own memory, and its own processing capability. So when combined with processing capability and physically existing some memory, these two represents a node. How do we represent a node? A node is represented as a cube. So a cube represents deployment. A cube can have a name within it. A name can be a simple name or a path name. A path name indicating that the nodes are existing within a package. So when they exist within a package, a package name followed by the name of the node represents the path name, or individually you can represent it by the simple name. And additionally, a node can also be attached with some tagged values also, and some stereotypes can be attached to it, which marks it that you can attach more compartments to a cube. So physically denotion, how do we show them? So this is an example. There is a kiosk represented as a node. There is a sale that is represented as a node. There is a path name being shown here that it's a backup. So it's a backup. Backup is a node again. So a server, which can be a backup server or a physical server, can be represented as a node. Yes, when you stereotype the same nodes, you can have your own forms of icons being represented here. So you want to represent a server physically being shown as not rather than as a cube, but we would like to show it as a physical existing server, your own notations being used, your own icon being used. Yes, it is feasible to use by representing a stereotyped node. Denoting a node with a component, when I relate a node with a component, which we call them as physical elements, a node can have multiple components within it. So a component cannot have a node, but a node can have multiple components within it, a single or multiple components within it. So components are the things that participate in the execution of a system, and nodes are the things that execute the components. Other key interesting differences: components represents the physical packaging of otherwise logical elements. All logical elements are combined together. Like for example, we said classes can be combined together, interfaces can be combined together to represent it as a single component. So it's a collection of physical packaging of those logical elements, but node is physical deployment of components. So it's at a higher level. So you all can bring in different components together and put it at one node, one physical location. That one physical location is rendered as a node. You see here there is a sales node. It is being interrelated with a dependency relationship with two components. What are those components? A POS and a contact.exe. So both of them being rendered as a component, and so these two components 1 and 2 are physically existing at a node called sales. So these are existing at sales. So someone wants to use a POS device, he has to access the sales and bring in the POS device. So that is existing in the sales component. And among the nodes, you can render different connections. A connection is a simple physical relationship shown among nodes. So how do we show it? We show it by a simple line. A simple line shows a connection. So you like to relate two nodes together, relate that these two are physically connecting for a data transfer, or they are communicating, they are sending message one to the other one, it is sending data, they are sending controls. All that physical relationships can be shown with the help of a connection. We will not talk it as a specific relationship, but it's a kind of simple relationship that exists only between nodes, only between nodes. So if you relate them physically, you will call it as a connection. So it's like showing that there is a telephone line between two devices. That telephone line can be shown as a simple connection. So we will not relate it as a relationship. One is not depending or doing anything. So we will call it as a simple connection. That connection can be shown by a simple line. What is a deployment used for? A deployment is used to model processes and devices. So as you can carefully look at the other diagram, you will find that there are servers that were rendered, a capability of having processing capability. So and so we will call it as processor. And these are also can be devices, like you have a server, there are certain other individual systems that are connecting, clients that are connecting to a server. All those clients now can be called as a device. So your physical deployment nodes can represent a processor or can represent a device. So how do we do that? When you bring in a scenario of how physically certain devices are connecting, like a client server architecture is being represented, yes, you show different clients and there is a server. So a physical connection between a server and those devices can be represented with the help of a diagram, a deployment diagram. So the components within the deployment diagram are shown by the nodes that I have. This is a node, this is a node, this is a node, and this is a node. The central node is a processor. We have specifically said that this is a processor named as a server, and all other are clients. There is a kiosk, there is a console, there is a RAID form where the data all gets stored. A RAID form, a console is being connected by RS-232, a simple network connection, and an Ethernet connection. So in any way, the connections shown are the standard lines, and the nodes that are shown here are playing their own roles. So the internal one, the server, can be treated as a processor, and the devices are kiosk, console, and RAID form. So all those can be treated as a devices. And next, deployment can be used for distribution of, they can be used to model distribution of components. Yes, we have logically collected and created a number of components within our system. Those components can be related with each other and rendered physically at a location by a node. So how do we do that? That's what distribution of components is. So how do we distribute? So physically, when components are being created, identify those components that relate with each other without the dependencies of where they are located. In such a case, they can be split anywhere, they can be distributed anywhere. But if they need to exist at a single location, they have to be collected into a single node. If they have no restriction of such a case, then those components can be rendered at any form of nodes that I have. So physically allocatable forms or basing on the dependencies. So they are closely related, one depends on the other one, then they have to be put on the same node. But if they are not having such a dependency, then they can be kept at different nodes where they can interact with the help of the connections that I have between the different nodes I have. So physically denoting it, the same form of diagram that we previously represented for processors and devices can be rendered as distribution of components now. How did we show it? The same kiosk has been represented as the same kiosk has been represented as a node now, a console has been represented as a node, and a RAID form has been represented as a node. Now the notation is a physical node representation along with the server. You can see that there are components additionally added to it. So 1, 2, 3. So this is an attribute field, this is an operation field, and this is a responsibility field. So you can have any number of fields physically represented for nodes also, as in the case of components, as in the case of classes also. Whenever we say that, we can physically attach a tagged value, you can add a stereotype, you can add multiplicity, all physically existing additional properties that are applicable over classes, and in turn applicable over components, and so in turn applicable over the nodes. So all that is the distribution of the components. Thank you.